Hello student, this is the topic for today, which is arches, which is one of the important topic for objective point of view. Generally, they are not asking the conventional question from this topic, but they are asking objective questions again and again on this topic. So you have to prepare this topic properly. Mainly the formulas are there. You have to remember those formulas. Let's understand the basic concept behind the arches. Now, what is basically an arch? Arch is basically a structure which is having a shape like this. It is having a shape like this. This is basically an arch shape. Now, arch can be classified into different types. Number one, the first basic type of arch is three-hinge arch. Is a three-hinged arch. Now, what is three-hinge arch? As the name suggests, it will be having three different hinges. For example, this will be the arch, and this will be having three hinges. The first hinge support is here. The second hinge support is here. And the third hinge is present at the crown. This is known as the crown. This is the third hinge. This is support A. This is support B. Now, this will be having reaction RA here. There will be a horizontal reaction, horizontal response also, which will be HA. This is RB. And there will be a horizontal response also, that is HB. It means that in a three-hinge arch, you will be having three different hinges, A, B, and C. It means that if you will go for the calculation of the indeterminacy, and you will calculate the indeterminacy, then this type of arc is basically a determinate structure. This is a determinate structure with degree of indeterminacy to be equal to 0. Its degree of indeterminacy 0 hoti hai. This is a determinate structure. Similarly, there are another type of structure which is known as two-hinged arc. This is the two-hinge arc. As the name suggests, this will be having two different hinges at the support only, because support pe requirement hoti hai. So in a two-hinge arch, it will be having a shape somewhat like this, which will be having hinges, one at this support and another as this support. This is hinge and this is support A, this is support B. Reactions again RA, there will be HA, again RB, and there will be HB. Now, as there are two different hinges for a two-hinge arc, this particular type of structure is indeterminate. This is indeterminate with a degree of 1. This is 1 degree indeterminate structure. The third type of arch is basically the fixed arc. The third type of arch, which is not in our course actually, is a fixed arch. Fixed means this will be having a fixed support here. This will be having a fixed support here. This is a fixed arc. This is totally indeterminate. This is an indeterminate structure which is having a degree of indeterminacy to be equal to 3. 3 degree indeterminate hota hai fixed arc. Now let's understand the concept of arch. Arch की अगर आप बात करते हो, basically if you are considering an arch like this, आर्च जनरली यूज किया जाता है when the structure, when the span जो होता है आपका वो बहुत बड़ा हो, जब आप बीम बना नहीं सकते. In that case you generally go for arches, जब span बहुत ज्यादा जा रहा होता है. Like if this is an arch, this is having a UDL, this is having a certain load over it. Let's say that it is having a UDL of W kilonewton per meter over it. ये जो UDL है, यही UDL बीम के ऊपर भी आना था, यही UDL आर्च के ऊपर भी आना. Let's see the difference first, कि दोनों में difference क्या है. If this is the UDL, the same load will be coming over the beam. अगर आप beam बनाते, this is W kilonewton per meter of UDL which is coming over this particular arch. You know that this will be reaction RA, this will be the reaction HA, this will be the reaction RB, and this will be the reaction HB. Now the concept says that if this is the total span of the arch, आपके total span जो है आपका arch का, that is, if you will say that this is total is L, which is the length actually, this is total is L, this is L, and let's say that this total rise is Y, or you can say that it is H. इसको H बोल देते हैं. If this is small h, total sag, or this is total rise is small h. And now if you are considering a certain section, let's say that we are considering this section for the calculation of the moment for the design, because you know that for the design you have to calculate the moment, चाहे beam हो चाहे कुछ भी हो, you have to calculate the moment. For that we have considered this particular section of the arch, and now in this section you are calculating, let's say that this particular section is at a distance of x and at a distance of y, which is the vertical distance and the horizontal distance is x from the support A. then in that case, if you'll go for the bending moment at mx, then in this mx will be ra into x. इसको होल्ड करना है, मैंने आपको सिखाया है स्टोम के अंदर द साइन कन्वेंशन, क्लियरली मैंने आपको एक्सप्लेन किया हुआ है. यू हैव टू होल्ड दिस पॉइंट and now this RA is trying to rotate it to create a movement like this, which is a sagging movement. In that case, the moment will be RA into x, which is positive, minus. Now this W is going to create this type of movement. It means this is minus in W into x by 2, because this portion is you have considered to be x. This is x. This is the x portion. Minus, again this HA is also trying to create the same movement as that of the UDL. So it means that this will be minus ka, this you are considering this point, minus ka HA into Y. Now this will be the total moment at the section of X. It means that this particular moment is common. ये जो moment आ रहा है, this moment is common for the arch as well as for the beam, but this is the exceptional moment which is only present due to arc. This is a common moment. This will be present in beam also. अगर beam बनाते आप इसकी जगह तब भी present होता, अगर arch बना रहे हो तब भी present है. But this particular portion is present only in arch. It means that the arch movement. It means that the arc moment is basically equal to the beam moment. It equal to beam moment minus h into y. It means that arches are more economical. It means arches are more economical if you are going for large span. Because why you are going for large span it is economical? Why? Because the moment is reduced in the case of arches, and you know that you have to design the beam also for the moment. If the moment is less, then stability will be more. Easily आप उसको बना सकते हो. It means that arches are more economical, but for the longer span only. For in general, shorter span or general span, you consider. Now, this is the basic concept. Means that the arches will be economical if you are considering for larger spans, because the moment will be less. Now let's understand the concept behind the 3-hinge arch. Let's analyze the 3-hinge arch. Analysis of 3-hinged arch. इसकी एनालिसिस कर लेते हैं, उससे आपको किस तरीके से क्वेश्चन सॉल्व करना है, you will also get to know that. Let's understand that. एक मैंने बना लिया, I have just drawn this 3-hinge arch. This is a 3-hinge arch which is having a hinge at this point, hinge at this point, and there is a hinge which is present here also. This is also a hinge. Now for this arch, we are considering that this is having a UDL of W kilonewton per meter present over it. We are considering that this arch is to hold a UDL of W kilonewton per meter present all over its length. मान लो ये टोटल इसके ऊपर लगा हुआ है. This is W kilonewton per meter. Now let's create the dimensions also. इसके distances देख लेते हैं. Let's say that the spacing is L, the rise is H. This is the rise for the arch. This is the total span. This is, let's say, L. This is, let's say, H. Now what you are doing is that you are doing the same thing. You are considering a certain section which is at a distance of X, which is the horizontal distance, and Y, which is the vertical distance. So basically you are considering this particular point. This is the point which you are considering. Now what you have to do is that you have to calculate the reaction. This is RA, this is HA, this is RB, this is HB. Calculations कैसे करते हैं वो देख लेना. यहाँ पे ऑब्जेक्टिव में वैल्यू देख के निकालने को आता है. Now first of all, you know that you have equilibrium equation, summation of fx is equal to 0. It means that HA minus HB, this will be equal to 0. It means you can say that HA is equal to HB. Let's write them equal to H. दोनों की वैल्यू सेम है. It means that I will write them equal to H only. I will represent them with the help of H. Similarly, this RA plus RB, we know that this is equal to W into L. Let's say this is equation number 2, and let's say this is equation number 1. If RA plus RB is equal to W, then it means that you can use this equation, summation of moment about B is equal to 0. B में RA का effect means that this will be RA into L minus का W into L square divided by 2. This is equal to 0. It means that RA, this will be equal to WL by 2, and if RA is equal to WL by 2, then RB will also be equal to WL by 2, because RA plus RB is basically equal to W into L. It means that you have calculated the vertical reaction. Now the next aim for the analysis is to calculate the horizontal reaction for a 3-inch arc. This arc which you are considering is a 3-inch arc, which is a parabolic arc. There are two types of arches. One is a parabolic and another is a semicircular arch. Parabolic arch and semicircular arch, these are the two different shapes of arches. Both can be 3 inch or 2 inch. So we are considering this to be a parabolic arc now. बाकी के मैं आपको रिलेशंस डायरेक्ट बताऊंगा. वो डायरेक्शन आपको जितने भी रिलेशंस है, you have to remember those, cramp them. याद कर लेना, क्वेश्चन डायरेक्ट आता है. ठीक है. Now you have to calculate the reaction. It means that let's say that this is bending moment about c equal to 0. Let's write the bending equation from the left. c का मतलब होता है either from the right or from the left. Bending about c equal to 0 रखते हो. This will be RA into L by 2. c तो सेंटर पे है. RA into L by 2 माइनस का W into L by 2 नीचे जा रहा है into L by 2 का आधा L by 4. इस पॉइंट को होल्ड किए हो माइनस का H को मैं H लिख सकता हूं into स्मॉल h. दिस विल बी इक्वल टू कितना है 0, क्योंकि वो क्या है हिंज है. RA की वैल्यू यू हैव ऑलरेडी कैलकुलेटेड. दिस इज WL by 2. इट मींस दिस इज WL by 2 into L by 2 minus WL by 2 into L by 4 minus H into H. This is equal to 0. From here, if you will calculate the value of H, horizontal reaction for a 3-inch parabolic arc, then this H is equal to WL square divided by 8 into H, where small h is the sag. This is the horizontal reaction for a 3-inch parabolic arc. You have to remember this reaction. At each and every section of the arc, if you will zoom it, अगर मैं आज आपको थोड़ा सा जूम करके आपको दिखाता हूं, तो फॉर ईच एंड एवरी सेक्शन ऑफ द आर्क देयर कैन बी डिफरेंट टाइप्स ऑफ फोर्सेस प्रेजेंट. फर्स्ट टाइप ऑफ फोर्स इज नोन एज द रेडियल शियर, व्हिच इज हैविंग अ डायरेक्शन लाइक दिस. दिस इज द शियर फोर्स. This is the shear force at a section of x. This shear force is defined by the equation Sx is equal to Vx cos theta minus Hx sin theta. Vx means the vertical reaction, Hx means the horizontal reaction at a distance of x. This is the radial shear portion. Now what is theta actually? Theta is basically, if this is the horizontal reaction and this is the normal reaction, this is the normal thrust, ये normal thrust जो लग रहा है, this is the horizontal reaction Hx. Theta is basically the angle between these two forces, normal thrust and the horizontal thrust. Now the point is that the shear is given by this equation, and the normal thrust is given by the equation. This is Vx sin theta plus Hx cos theta. You have to remember this reaction, and this normal thrust is the only thrust which is present on a 3-inch parabolic arc. That is, in a 3-inch parabolic arc with a UDL all over the span, the shear force and the bending moment, everything will be 0. That is, here comes the note. यहाँ पे आपको ध्यान रखना है that for a 3-inch parabolic arc, the shear force will be 0. The bending moment will be 0 at each and every section. The only force which will be present is the normal thrust. हमेशा देखना ध्यान की जो भी force present होगा, this will be equal to 0. The force which will be present, that force will always be the normal thrust force. बाकी सारी forces 0 होती है, कोई force यहाँ पे present नहीं होता है. This is for a 3-inch parabolic arc. Now, if you are considering the same 3-inch but the semicircular arc, if you will go for the 3-inch semicircular arc, 3-inch semicircular arc, then in that case the horizontal reaction with the UDL all over the beam. पहला केस है UDL की बात कर रहे हैं, UDL all over. With UDL all over, then in that case the horizontal reaction for that particular case will be the UDL W into the radius divided by 2. This will be the WR by 2 for a 3-inch semicircular arc. If the arc is semicircular, this could be the case. तब ये case present होगा वहां पे. Point of contraflexure क्या बताया है? मैंने आपको बताया था, where the bending moment changes its sign. point of contraflexure will be 0. There will be no point of contraflexure in a 3-hinge arc. The bending moment diagram, if you want to draw, then the bending moment diagram will be like this. This is the hinge portion, this is the hinge portion, this is the hinge portion. The bending moment diagram, if you will draw, in that case the bending moment diagram will be like this. ये कुछ इस तरीके से bending moment diagram बनता है इसका, like this and like that. इस तरीके से this will be the bending moment diagram. It means that there is no point of contraflexure. This is positive, this is positive. और यहाँ पे जो मैक्सिमम बेंडिंग मोमेंट निकल के आ रहा होता है, द मैक्सिमम बेंडिंग मोमेंट विच इज प्रेजेंट हियर इज, सब याद रखना है आपको, द मैक्सिमम बेंडिंग मोमेंट विच इज प्रेजेंट हियर इज माइनस का डब्ल्यू आर स्क्वायर डिवाइडेड बाय 8. दिस इज द मैक्सिमम बेंडिंग मोमेंट विच इज प्रेजेंट, माइनस का डब्ल्यू आर स्क्वायर बाय 8. ठीक है. जनरली दिस इज प्रेजेंट व्हेन द वैल्यू ऑफ थीटा इज बेसिकली इक्वल टू 30 degree. For theta is equal to 30 degree. Theta I have already told you, which is the reaction relation between, which is the angle between, you can say that. अगर आप किसी भी पर्टिकुलर थीटा को कंसीडर करते हो, उस पर्टिकुलर थीटा के लिए निकालते हो, then that value of theta will be equal to 30, for which this will be maximum. थीटा का मतलब अगर आप यहाँ पे जनरली लेते हो, this will be the value of theta. ये तो आपका पैराबोलिक था. अगर आप सेमी सर्कुलर के केस में लोगे तो थीटा विल बी जिस पर्टिकुलर पोर्शन से आप, जैसे फॉर एग्जांपल यू आर डिजाइनिंग and now you are considering the section x, then now this particular angle which you have considered, जिस पे आपने x section लिया हुआ जितने एंगल पे, the angle which you have considered, जिस पे आपने x section लेके उसको कंसीडर किया है, यहाँ से आपका x डिस्टेंस आया था, यहाँ से आपका y डिस्टेंस आया था, this theta, this is the value of theta, which should be equal to 30, and in that case the bending moment will be maximum, which is minus का WR square by 8. Also, when the arch is semicircular, when the load is W at the crown, when the load is W kilonewton, सिर्फ W kilonewton लग रहा है, at the crown or at the center, then in that case the horizontal reaction will be equal to the vertical reaction at A, will be equal to the vertical reaction at B, and all these reactions will become equal and they all will be equal to W by 2. But this is only for a semicircular arc which is having load W at this particular crown portion पे अगर load आ जाता है, then in that case this will be the reaction. If the arch is a parabolic arc, but the abutments are at different levels, it is a parabolic arc, ये सब ऑब्जेक्टिव में आता है, बट द अबटमेंट्स आर एट डिफरेंट लेवल. अबटमेंट्स आर एट डिफरेंट लेवल का मतलब होता है द पैराबोलिक आर्क इज समवॉट लाइक दिस. दिस इज द पैराबोलिक आर्क. कुछ इस तरीके से है आपका आर्क, ज्यादा नीचे चला गया, थोड़ा छोटा कर देते हैं. नाउ इन दैट केस अगर आपके पास इस तरीके का कुछ केस बन रहा है, व्हेन द अबटमेंट्स ऑफ द आर्क आर एट डिफरेंट लेवल, लेट्स से दैट दिस इज अ लोड यूडीएल व्हिच इज प्रेजेंट ओवर द पर्टिकुलर आर्क. ये यूडीएल प्रेजेंट है. दिस इज द डिस्टेंस, मान लो दिस इज h1 जो आपका पहला वाला है, एंड दिस इज द डिस्टेंस विच इज, लेट्स से दिस इज h2 जो आपका दूसरा वाला है. h1 एंड h2. यहाँ इसका कहीं सेंटर जा रहा होगा जहां पे आपका हिंज लगा हुआ होगा. दिस पर्टिकुलर पोर्शन लेट्स से दिस इज L1 एंड दिस पोर्शन लेट्स से दिस इज L2. दिस इज L2. The load is W kilonewton per meter which is present over this particular arc. Then in that case the horizontal reaction H will become, which is HA and HB both, this will become WL square divided by 2 under root of H1 plus under root of H2. This will be the horizontal reaction, WL square upon 2 under root H1 plus under root of H2. ध्यान रखना है. Here L1, if you want, this is the distance L1. L1 is equal to L under root of H1 divided by under root of H1 plus under root of H2. Similarly, this L2 will be equal to, this L2 will also be equal to L under root H2 divided by under root H1 plus under root of H2. बाकी आप जानते हो bending moment, this is point C, bending moment at C will be 0, this you already know. समझ में आ गया. दिस इज WL स्क्वायर अपॉन 2 अंडर रूट H1 अंडर रूट H2. अगर यहाँ पे इस UDL की जगह आपके पास कंसंट्रेटेड लोड होता, इट मींस दैट इस UDL को हटा दो, भूल जाओ यहाँ पे एग्जिस्ट करता है. सिर्फ यहाँ पे सेम कंडीशन होता, बट लोड जो होता है वो W किलोमीटर पर मीटर की जगह सिर्फ W kilonewton is present. If instead of this particular UDL, the concentrated load of W kilonewton will be present, and in that case the horizontal reaction for this particular type of arc, which is having different level abutments, will become, this H will become WL divided by under root of H1 plus under root of H2 ka whole square. This will be the case in that particular point when the load is W kilonewton present over the crown, over the head. ये आपको ध्यान रखना है. This is 3 inch arc. ये 3 inch arc कुछ basic case है तो आपको याद रखना. 3 inch arc के लिए one thing you also have to remember that due to rise in temperature, the 3 inch arches which is having a vertical height, for example, if you take the example to understand the, if you take an example to understand the effect of change in temperature for a 3 inch arch, this is the effect of change in temperature. अगर आपको temperature का effect देना है, then for a 3 inch arch, the condition is that कुछ ऐसा होता है 3 inch arch. अभी पॉइंट ये है कि 3 इंच आर्च में जो टॉप पोर्शन होता है, दैट पोर्शन इज ऑलमोस्ट फ्री. दिस पोर्शन इज फ्री. तो व्हाट विल हैपन इज दैट व्हेन यू विल इंक्रीज द टेम्परेचर, दिस इफ आर्च इज इनिशियली अनलोडेड, अगर अनलोडेड है, इफ द आर्च इज इनिशियली अनलोडेड, कोई लोड इसके ऊपर है नहीं, द आर्च इज इनिशियली लोडेड, देन देयर विल बी नो इफेक्ट on the reactions, no effect at the support. लिख लेते हैं at the support अगर ये unloaded है. But if the arc is loaded, and now what you are doing, you are increasing the temperature, then this vertical height of the arc will increase. This will increase delta H. If this is small h, then this small h will increase by delta H. In that case, this H will increase if it is loaded initially. And if the H will increase, then it means that H is equal to, you know, that WL square upon 8 into H. If this H is increased, then it means that the horizontal reaction at the support will decrease. It means for a 3 inch arc, if it is loaded, then there will be the changes in the support. अगर unloaded है तो कोई change नहीं आएगा, and that change will be the decrement in the horizontal reaction, and the vertical reaction remains same. There will be no change in the vertical reaction. This is the case for a 3 inch arch. 3 inch arch के लिए temperature changes का effect होता है. Fine. ये जो मैंने आपको यहाँ रिलेशन लिखे हैं, these relations you have to remember for 3 inch arches. ये क्वेश्चन आते हैं एग्जाम में तो ध्यान रखना इन चीजों को, otherwise you will get confused. अब बात करते हैं 2 inch arch के लिए. 2 inch arch. The next is 2 inch. Now, as I told you that the 2 inch arch will be indeterminate, you already know that indeterminacy will be calculated like ds is equal to 2 inch, 1, 2, 3, 4, 4 minus number of equilibrium 3. It is having a 1 degree indeterminacy. पहली बात तो 1 degree indeterminate. It means that to analyze this particular arch, you will be requiring some addition equation. Without addition equation, you cannot analyze this particular arch. After the analysis, if you will calculate the horizontal reaction and all that, then you will get to know that for a 3 hinge arc that is having a horizontal thrust of WL square upon 8H when the UDL is present, this particular horizontal thrust will be same for the 2 hinge arch also. It means that for a true hinge arch which is having UDL all throughout, this 3 inch arch, this 2 inch arch will also have the same horizontal reaction, that is WL square upon 8 into H. This is for a 2-hinged parabolic arch. This is for a 2-hinge parabolic arc. The 2-hinge parabolic arc will have the same horizontal thrust as that of a 3-hinge parabolic arc. Same case बनता है. But the point is little different. If you will increase the temperature in case of 2-hinge arch, अगर वहां पे तो loading unloading का case था, but in case of 2-hinge parabolic arc, if you will increase the temperature, then for a 2-hinge arch, there will be an increment in the value of H. H will increase because for 2-hinge arch, this is not free to expand. ये expand नहीं हो सकता है. It means that To handle this particular temperature change, the horizontal reaction will increase in case of 2 hinge arc, but it will decrease in case of 3 hinge arc when it is initially loaded. अगर loaded होगा तो ही ऐसा होता है. Now, if the arch is 2 hinge and it is a semicircular arc, if the arch is semicircular with concentrated load of W kilonewton at the crown, concentrated load of W kilonewton at the crown, then in that case the horizontal reaction will be equal to W upon pi. This will be the horizontal reaction if the load is present at the crown. If the load is present at any angle alpha, if the load is present at any angle alpha, alpha means the angle like this. If this is your 2 hinge arch, ये हमारा 2 hinge arch है. Now the load is present here. And let's say that this load is having an angle of, if you will measure this angle from the center of the arc, then let's say that this angle is alpha and this is load of W kilonewton. Then in that case the horizontal reaction which will develop to handle this load W, this H will be equal to W upon pi sine square alpha. This you have to remember. This will be W upon pi sine square alpha. Similarly, if this semicircular arc is having UDL, ये load हटा दो. Now just remove this load. Now it is having, let's say, UDL. अब ये load नहीं है इस पे. Now this semicircular arc is having UDL, 2 hinge है और UDL है इसके ऊपर. Then in that case, if UDL is present for a 2 hinge arc, then in that case the horizontal reaction will become 4 upon 3 into WR divided by pi. 4 upon 3 WR by pi. In case UDL is present. If UDL is present, this is 4 upon 3 WR upon pi. अगर UDL नहीं है, if in place of UDL, if UDL is not present, in case place of UDL, it is having UVL. इसमें UVL present है. Like this. If it is having UVL over it, UDL नहीं है, UVL है. W kilonewton per meter का अगर इसके पास UVL है, which is having a load of W kilonewton per meter maximum, then in that case the horizontal reaction will become 2 upon 3 WR upon pi, which is half of the horizontal reaction when the UDL is present. This is for the case of UVL. ये सब याद रखना, ऑब्जेक्टिव में डायरेक्ट आता है. This is the case of UVL. If in case of a parabolic 2 hinge arch, as I told you, if the UDL is not present throughout, यहाँ पे क्या था, UDL is present throughout. If the UDL is not present throughout, it is present in the half the length. Half length पे present है. Half length का मतलब जैसे ये अगर आपका है तो सिर्फ इतने में UDL है, आधे में. Then in that case, this horizontal reaction will become WL square upon 16H, which will become half. If the UDL become half, then this particular reaction will also become half. Similarly, this is for parabolic 2 hinge arch. Similarly, if the arch is parabolic and it is having UVL, अगर ये semicircular होता, this is UVL for semicircular. But if the UVL is present and the arch is parabolic 2 hinge, then in that case, the horizontal reaction will be WL square upon 16H. Remember that. Parabolic का different case है, क्योंकि parabola का different equation होती है. तो case is also different for parabolic. But in case of this, अगर आपके पास semicircular है तो ये case बनेगा. Otherwise, case will be different. If the arch is parabolic, if the parabolic arc is present, parabolic 2 hinged arc is present, 2 hinged arch is present, and it is having a concentrated load of W kilonewton at the crown. Crown का मतलब होता है top portion. अगर crown पे बैठा हुआ है W kilonewton, then in that case the horizontal reaction will be 25 divided by 128. ध्यान रखना ये W है लेकिन parabolic है, वो semi circular था, W upon pi था. 25 upon 128 WL upon H. This will be the horizontal reaction in that case. 25 upon 128 WL upon H. ये केस बनता है. कब बनता है? When the arch is parabolic. अगर parabolic है then the case will be this. Otherwise तो you know that. समझ में आ गया होगा. ठीक है. There are some special cases also. There is some special cases also. Let's understand those cases. Special cases. ये सब नोट कर लेना, सार में नोट्स बनाते रहो. इसके वीडियो में मैं सारी चीजें करा दे रहा हूँ, इसके अलावा कुछ पढ़ने की जरूरत नहीं है. बस just have to make the notes with the videos. In videos के साथ just keep on writing the notes. Special cases. Special case में पहला first special case is that the horizontal thrust H को बोलते हैं horizontal thrust in two hinge semicircular arc due to rise in temperature by delta T degree centigrade. If you will increase the temperature by T degree centigrade, then the horizontal thrust will be 4EI alpha T divided by pi r square. This will be the horizontal thrust when the temperature variation or the temperature increment is T. When the temperature increment is T, then in the two hinge semicircular arc, the H will become this. Similarly, if the arc is not semicircular, if the arc is parabolic, then in that case, for the parabolic arc, the H will become 15 upon 8 EI alpha T divided by H square. 15 upon 8 EI alpha T upon H square. यहाँ पे I जो होता है, that I is basically the constant value. I is not changing. It is the moment of inertia at the ground. This is the special case. यहाँ पे एक reaction law होता है. वो reaction law ये कहता है कि the reaction locus is basically the point of intersection of two resultant reaction at the support. When a point load is moving from one end to another end, ये reaction law ये कहता है, there is a reaction law. Now what the reaction law says? Reaction law says that if this is an arc, and in this particular arc, which is a 2-inch arc, you know that there will be two different reactions. One reaction will be like this, another reaction will be like. Similarly, there will be two reactions here. Because of these two reactions, there will be the resultant reaction which is present here also. There will be the resultant reaction which is present here also. When you will just increase the line of action of this resultant reactions, and you will consider that a load of 1 kilonewton, ध्यान से सुनना, ये सारे resultant reaction है. This is resultant 1, this is resultant 2. There is an intersection of these two resultant reaction, and if this 1 kilonewton load is moving from left to right, then in that case, if you will just join these two reactions, line of action of these two reactions, then you will form a particular type of curve. That curve will be having a shape somewhat like this, and for this particular curve, this particular height is basically equal to 1.6 times small h, and this particular height for this curve is equal to 1.28 h. This is 1.28 h. So you have to remember that कि अगर आपके पास ये दो reactions है, ये दो reactions है, these are the final resultant reaction on the two support. तो ये दो resultant reaction, they will intersect at a point, and that point of intersection, if you will form a locus of joining all the points of intersections, when 1 kilonewton load is moving from left to right, then that locus will form a curve. That curve will be having a height of 1.6 h above this particular support, and 1.28 h above the ground. There is another term also which has been asked in the objective question, that is theoretical arch. Theoretical, or they are also saying that this is a linear arc. Theoretical or linear arc is basically that arc which is only having axial compressive forces in that. The shape of the theoretical arc is somewhat like this. This is the shape of the theoretical arc. If you go for the theoretical arc, will be having a shape like this. कुछ ऐसी shape होती है इसकी. This is the shape of the theoretical arc. ये होता है theoretical arc. This is the linear arc which is only having axial forces. This is A, B, C, D, E. Curvature हट गया, इसके पास सिर्फ axial forces इसमें present है. So this is known as theoretical arc or linear arc, which is only having axial forces, which is free form. Actual में भी bending moment shear force आ नहीं होता, तो shape ऐसी बना दे जाते हैं. ये theoretical है. It is free from shear force and bending moment. there is a concept which is that there is a theorem actually which is known as Eddy's theorem. There is theorem which is known as Eddy's theorem. Eddy's theorem ये कहती है, the Eddy's theorem says that if the linear arc is superimposed, if this linear arc, if you will superimpose this arc, if you will superimpose this arc over the given arc, over the given arc, जो भी आपका actual arc होगा, if you will superimpose the linear arc on the given arc, then the bending moment at each and every section of the given arc, then the bending moment for the given arc will be directly proportional to the intercept between, will be directly proportional to the intercept between the theoretical arc, जो भी गैप होगा, and the given arc. मतलब ये कॉन्सेप्ट ये कहता है, if you are having, this is your arc, मान लो given arc है आपके पास, this is your given arc, ठीक है, this is your given arc. Now what you are doing is that you are just superimposing the linear arc over the given arc. Superimposing how? You are superimposing like this. आप इसके ऊपर आपने सीधा सीधा बोला रहा आर्क रख दो अपने, जो ऐसे आप रखते हो. This is your linear arc. If you are superimposing this linear arc over this given arc, then you are getting a certain intercept. This is the intercept which you are getting everywhere. This is the intercept which you are getting. Then in that case, the maximum bending moment, if you want to calculate, for example, this is the intercept delta of y, this is a superimpose. If you want to calculate the intercept, if you want to calculate the maximum bending moment, then the bending moment at any section x will be directly proportional to the intercept between the linear arc and the given arc. This is the given arc, जो नीचे वाला है आपका, जो आपके पास given होगा, and this is the linear arc. दोनों के बीच का जो गैप होगा, that will be directly proportional to the bending moment. इतना आपको ध्यान रखना. This is Eddy's theorem. Basic objective के लिए ध्यान रखना, कुछ ज्यादा डेप्थ में नहीं आता है. Fine. So these are the things which you have to remember in the case of Archie. These are formulas which I have written. Just keep on learning, keep on revising. इन सबको note down कर लो, बहुत important है ऑब्जेक्टिव के लिए. फिर से बता रहा हूँ. Thank you. Bye bye. Take care. Have a nice